it out. So this problem, the hint that I would say is you want to choose x to be 3 sine of some new variable, which I'll call theta. And then dx becomes 3 cos theta d theta. And so the integral becomes 27 sine cubed over the square root of 9 minus 9 sine squared theta d theta. And so this simplifies to some stuff. And you're going to get an expression in theta. But that's not the final answer because the original variable was in terms of x. So I'm not going to do this integral because, you know, if I go any further, I'm kind of giving it, I don't want to say giving it away, but I'll leave it up to you. And so to finish the problem, you need to sort of return to the original variable, which is x. So to do this, and sort of the way to go about it is you draw a triangle. And so let's take a right triangle. In our original sort of relationship is we use that x was 3 sine of theta. So what if I call this angle theta, then the sine of theta is x over 3. So I would label this as x, and this is 3, and then this becomes 9 minus x squared. And so what this tells us then, for example, is that cos of theta is this. Adjacent over hypotenuse tells us that theta is the arc or the inverse sine of x over 3, etc. So you would read everything off this triangle. Does that make sense? How about here in the room? You guys have any questions about this? No. All right, great. See, that's good. Yeah, I don't know what was happening, Cammie. I kept getting kicked off too. So I don't know if Zoom was trying to ruin our day or what, but wasted a few minutes. Does anybody else have a question while we're at this? I'm happy to give hints and all that. How about here in person? You guys good? What's that? Absolutely. I like that answer. Absolutely.
Stress out to you.
Yes. What did they say? Was speak better English. Got to get as good as me, right? Meanwhile, my English is terrible. Yeah, you have a better excuse than I do, though. You're learning it. I'm supposed to know it. All right. Does anybody else? I don't want to introduce anything new today, so I'm willing to answer any questions about homework or the midterm, but I'm not going to. We'll start everything new on Tuesday. We're not going to do Taylor series yet. We're going to do a couple differential equation things first, and then we'll do Taylor series. I think, or maybe we will just go in the series. I haven't decided yet. Well, what's going to really matter is how well you guys do or how poor everybody does on the exam. That'll depend on what we do next. There's someone's chatting up. All right. 5D. Which one was that? Which one was 5? Was that the one with the e to the negative x squared?
Yeah.
Yeah. Yeah, so 5D, that's the hard part. So here, let me give you guys a little bit of something to think about that. So this is an important problem because what happens is, so here's number 5. So the goal is to show that this improper integral, 0 to infinity of e to the negative x squared dx, converges. That's the goal. Now, this is a hard problem, so I broke it into steps. Now, you might not realize that yet, but that's sort of what I was doing. So the first thing is part A. And part A wants to show is you need to explain why this integral from 0 to 1 is less than 1. Now, I gave you a hint to do this, and the thing to remember is you can't compute this integral because there's no antiderivative. So you can't just use the simple formula, but what you can do is you can draw a picture, and it's very clear when you draw a picture. So what do I mean by that? Well, if I draw my XY axis, and I draw some, let's label this point, which is 0, 1. And if you go to Desmos, that's fine too. And then let's say this is 1. So if I draw the graph of e to the negative x squared, the graph looks like this. I mean, it comes up, has this bell-shaped thing. This is a very poor, let me try that again. I'm sorry, guys. My penmanship is suspect. So this isn't a great scale, but it is, this thing should be symmetric. And so what this integral we're worried about here is this shaded region. And the point that I hope you guys take from this is if I take this red box and I just say, okay, well, here's a square of area 1. So the red square has area 1. Is 1, and then of course what this is this integral is the area under the curve. And so if you asked, say, a 5th grader or a 10-year-old, what's bigger, the square or this shaded blue region, they're going to tell you the square. And so if we write that in calculus, that's what this means. Okay, so that's part A. Does anybody have a question about this? And I know you asked about part D, but I'm going to try to build to that. So this is sort of what you need to do for this problem. Okay, now the next part is to look at what happens a little further down the real line. And so what do I mean by that? Well, I mean, if I just draw over here for a second, let me take, okay, this is say 1 and this is 2, and then you might be better off going to Desmos so you can see how this really works. But if I take my blue curve again, graph looks like this. So again, the blue curve is y equals e to the negative x squared. And now let's draw a similar function, which I sort of gave to you guys. And that is this guy. So the red curve is y equals negative x. So that guy goes like this. And so what's important to understand here is that the area under the blue curve so the area under blue curve on 1, 2 is less than the area under the red on 1, 2. So we see that in English. That's the point we're trying to make. And so what that tells you in terms of integrals is it tells you that this integral is less than this integral. Now, why would we care about this? Well, we care about this because we can actually calculate this. So we can compute this one. I'm not going to do it for you. It's an elementary integral, but you should go through it. Well, yeah, it's -1. It's, yeah, it's right. It's negative e to the negative x, and then you plug in from 1 to 2. You can compute the number. So what you need to argue then is, and what I really hope that you do is what can you make from this? What can you conclude? Well, the thing to understand is that, and this is the key idea to help you with D. So the key idea is when x is greater than 1, e to the negative x squared dx is less than e to the negative x. So one thing which you should do is, I'm telling you it's true, and you can use that it's true, but if you want full credit, you need to show why. Can you explain why? Or as we like to say, can you show why?
It diverges to 1. So.
What do you mean diverges to 1? I don't know what you mean by that. You can't, when you talk about diverge, there's no integral here right now. No, I want you, don't think about integrals right now. Can you show this is true? Because the point is, if you draw the graph, it's clear. If you go to Desmos and graph these things, it's going to be clear. But I'm asking you, can you show using calculus or any means why this inequality is true? Now, if you can, how do you want to do it? Just
so we will just, minus x squared and minus x negative x. If we just look at this, it is obvious that minus x is bigger than.
That's correct. So the suggestion made by Volcker is correct, in that if you know that e to the minus x is, if you know that it's a decreasing function, which we do know that because its derivative is negative, then we know that this is true because it's a decreasing function. As you suggest that x squared is bigger than x when x is bigger than 1, and so that's true. But you should explain that if you want full credit. Now, this is a hard problem. Very few people, if any, will get full credit on it. That's okay. But our goal is to try to convince you to strive to write great mathematics. Okay, so even if you don't explain why it's true, even if you just assume it's true, which is clear by the picture, there's nothing special about me going from 1 to 2. So what this means is, and I hope you'll follow this logic, this means if B is any number larger than 1, that the integral from 1 to b of e to the negative x squared dx, this is always going to be less than the integral from 1 to b of e to the negative x dx, which you can compute. So then the limit as b goes to infinity of 1 to b e to the negative x squared dx has to be less than this limit. Now, what does all this mean? Well, I'm not going to put the puzzle together for you. I've given you all the pieces. Your job now, especially being that this is an exam, is to figure out how to put these pieces together. So the ultimate thing now is, can you use all these things to do part D? Put these pieces of the puzzle together and explain to me why. So your job. use the above stuff, and that's parts A, B, C, etc., to explain why this thing must converge. Now, I'm not saying this is easy. In fact, I've told you a few times now this is very difficult to do correctly. But it is a very important problem, and I like, in the past I've given this problem in similar ways, and a few people have gotten it, and that's good. You don't want to get disappointed in yourself if you don't get it. This is a hard problem, but if you do get it, that's a great thing. Can you put these pieces together? Can you give a logical argument to why this thing must converge? I've done the work for you. You just have to put it together in the right way. Well, that's the point. If I tell you any more, I give the answer away. I don't want to give it away. But I hope you'll think about it. I hope that gives you help. And I don't mean to be like a buzzkill, you know. I know that I said I'll give you hints, so there you go. So the beginning parts, A, B, and C, and the stuff that I did on the previous page, those are all the pieces you need, Becca, and you just got to figure out how to put them together. All right? So hopefully that gets you started. And by the way, as some of you know, and many of you have had class with me before, so you'll understand, you don't have to get everything correct to get an A on this stuff, right? And you should, I don't mean to say this to bring your sort of your mojo down, but this material is difficult. You can't get down on yourself if you don't understand everything. And just because, even if you don't ever understand everything, that doesn't mean you can't earn a good grade. So keep that in mind. If you might feel like, of course, there's going to be extra credit. You know this. Becca asked for it. There's always extra credit. And by the way, I feel bad. I just told Calc 1, I updated everybody's grades, but you guys, I'm a meanie. I got to get your grades in there. And I look forward to grading these exams tomorrow night. It's Friday. What better thing to do on a Friday night than grade calculus exams? No, I won't do that Friday night. No. Tonight's my anniversary, actually. It's my 9 years of marriage tonight.
Okay.
Yeah, congrats. Woo. Anyhow, what's that? Yeah, I have survived. This is true. Thank you, Becca. I have 2 children. I have a 5-year-old and a 2-year-old.
One of them decided to break their arm.
Oh yeah, you remember that? Yeah, Ricky did last summer. That was in March. Oh, I'll never forget. It's right, because that was during Calc 1. What's funny about that is
I laughed and I said,
"Oh, she's crazy." We had, when that happened, Becca and Cammie and Naomi, you wouldn't know this because this was in March. But was it March? Yeah, because it happened the week after the corona hit. My 2-year-old decided to fall off a table and break her arm. So we had to take her to the hospital in the beginning of the Roni, when everybody thought we were all gonna die in a week, right? It was wild. And then this is when we were doing all this. Well, you guys may have seen Ricky in the Zoom or something over the summer, because she would come downstairs and raise hell. She's crazy.
Does she know integral or something like that?
No, she doesn't know integrals. My older kids, so this is actually a good story, not that you care, and please, you guys can leave if you want. My 5-year-old she's in kindergarten, and they give her these calendars. I was very impressed by her yesterday. She figured out subtraction, but she didn't understand that she doesn't know it's subtraction. But she was counting how many days are left till Halloween. And then she figured out that since there's 31 days in October and the 7th was yesterday, she deduced how many days were left. And I said, Lydia, you just learned subtraction. And she has no idea what that means, but it was funny. She's like, okay, Dad, whatever. But, it's funny how you learn stuff when you're not, when you want to do it. She was over there counting. I was like, good for you. She's like, I'm practicing my numbers. So I think she'll be a legend. Ricky, she might be destined for other greatness. Maybe wrestling or something.
I had got one teacher, we had class, and he was sitting there and he was just 9 years old, and I asked, you say good at math, and he said he has some problem in integral, but the rest of it are okay. Like, literally, he's preparing the Olympics.
Mhm.
Like,
Well, when I was in graduate school, I was a TA for a class. So at big universities, you have a professor for calculus, say, and then 2 days a week you meet for a lecture 3 days a week, and the other 2 days a week you meet with a graduate student, and they like help you solve problems and stuff. There was a 12-year-old in my one class. Yeah, he was very smart. Yeah, he was. I said, well, I was worried he was smarter than I was. There are some people like there's definitely people that are exceptional, right? You see lots of them on TV when they play sports, right? So that's the wild stuff there is. All right. Does anybody else have a question? No. All right. Well, do you guys? So what we gotta let? Hold on. I just know.
I've got just one question.
Yeah.
Like,
What's
I have
that? I just hit the.
solved it, I have solved it, but I have to compute it. Like, where do I compute this one?
Which one are you talking about?
Like, it is 1, 8. Yeah. Like,
Just bring it up. Use your calculator. That's what I did.
For which number? Which
like,
one?
no, it's just super easy. I have solved everything, but I have to compute this.
Yeah, so use your
1
calculator.
plus.
You talking about the arithmetic? Yeah. Don't waste your time. If you're talking about you talking about the problem 4?
Oh, yeah.
Yeah. So like I said, guys,
And
if
then
you.
for minus L1 is equal to this
Yeah,
one,
you
because FTC says like FB minus FA.
Yeah, correct. So what I would tell you, so the question is, or the point was being made, like on problem 4, you don't have to do all that arithmetic by hand. You can, you need to at least show me that you know the trapezoid method and Simpson's rule by writing the formula down, but I don't expect you to do that by hand. You could plug those into a calculator.
Just write the actual formula first.
Well, I mean, at some point, okay, so the question was, do you have to write the actual formula for problem 4, the second and third part? No, in a sense, but don't just write a number next to the integral. I want to know that you actually set it up properly, right? Does that make sense? So you got to tell me what dx is. You have to tell me, do you understand? Yeah, you should. Don't just write a number. Right?
I wrote the formula, but then I did write like f of x. I just wrote the numbers.
That's fine. Yeah. That's fine. You don't have to do all that. I'm not expecting you to write it out. Your head will explode.
Like,
And look, I showed you can use Desmos and calculators to do that. Yeah. You want extra credit, Becca? There you go. Write a computer code to do the trapezoid rule for you.
I can do that.
Yeah. Yeah, then
Like,
do it.
it's just literally like one thing we will do, like x car is equal x0 plus car times delta x, and you can call delta x.
Yeah, call whatever the heck you want. Yeah.
And you will just put fx.
Yeah, it's actually easy. Yeah. All right, gang. Any other questions before we wrap it up? 5, 4, 3, 2, 1. All right. I'm going to stop recording. By the way,